Okay, so the last skill that we need on this unit is to be able to use our approach to trigonometry to find sides. And we're going to have a look at two worked examples here. So I've been asked for the first triangle to find angle A. I'm going to look at angle A first and then I'm going to look at angle B afterwards. So if I'm looking at angle A, well, we know that my hypotenuse is here. It's opposite the right angle. So from A, 6 is going to be the opposite. And then this is the adjacent, which we don't need. So looking at my SOHCAHTOA, I'm just going to rewrite it out for myself. SOHCAHTOA. Looking at my SOHCAHTOA, I know that my opposite and my hypotenuse are connected by sine. So I can now rewrite that as sine of A is equal to my opposite, which is 6, divided by my hypotenuse, which is 8. Sine of A equals 6 over 8. Put on my calculator 6 over 8. 6 divided by 8 is 0.75. So sine of A is 0.75. Well, remember what this is telling us. If I've got my angle A and I sine it, it gives me 0.75. What I want to do is find out what the angle is. I know that the sine of the angle is 0.75, and I've got a button on my calculator which lets me do that inverse operation, which is sine minus 1. And on most calculators that would be shift sine 0.75. So I can say that A equals sine minus 1, 0.75. Let's just show that on the calculator. So I'm going to type shift sine, and you'll be able to see just above my sine key there's a sine minus 1. Shift sine, and there it is on my screen, 0.75. And it gives me an answer of 48.6 degrees. So A equals 48.6 degrees. Let's try and do the same if I was trying to find angle B. I'm going to get rid of my scribbles up here because it's going to be different now that I'm standing at B. The hypotenuse remains the same, still opposite the right angle, but this now is next to my angle, so this becomes my adjacent and this becomes my opposite. So standing at B, I've got my adjacent and my hypotenuse, so I'm looking at CA, adjacent and hypotenuse. So I can say that cos B equals my adjacent, which is 6, divided by my hypotenuse, which is 8, which is 0.75. So here I can say that B now must be cos inverse of 0.75. Put it onto my calculator. Inverse cos of 0.75 gives me an answer of 41.4 degrees. Some of you may have seen that there was an alternative and perhaps a quicker way to get B, using the fact that angles in a triangle add up to 180. Notice I know that this is 90 degrees. I've already worked out that this is 48.6, so I can find my missing angle by doing 180, take away those two. It would have given me exactly the same answer. Okay, let's take a look at question 2. So question 2 asks me to find the missing sides and angles. Now, you can choose which you want to do first. You can look at finding the angles first, or you can look at finding the sides first. We're going to start by looking at the sides. So I've been given two sides. To find my third side, I'm going to use Pythagoras. So here, looking at Pythagoras, I'm going to be finding one of the shorter sides. So this is going to, so let's call this side A, and we're going to be able to say that A equals the square root of 5 squared take away 4 squared. 5 squared is 25, take away 4 squared is 16. Square root of 25 take away 16, which is the square root of 9, which is 3 meters. So I found that that is equal to 3 meters. Let's have a look at finding my angle. I'm going to call this angle B. Now, I've got lots of information that I can use to find out angle B. So I've got all three sides, so I could use any of sin, cos or tan. I'm going to use sin, so I'm going to say that sine B is the opposite over the hypotenuse, which is 5. Sine B equals 3 over 5. Therefore, B equals the inverse sine of 3 over 5. I haven't actually worked out 3 over 5 yet here, but I can just do it directly on my calculator. So I'm going to do shift sine 3 over 5 gives me my answer of 36.9 degrees. Let's have a look at finding angle C. I'm going to do the easiest way to do that, which is angle C is 180 minus 90 plus 36.9. Because I know this is 90, I know that this is 36.9, and angles in a triangle add up to 180 degrees. So let's just work out what that is. Gives me an answer of 53.1 degrees. So you should be able to see that from an example like that, you're able to find out all sorts of missing information from a triangle using a mixture of Pythagoras to find missing sides, trigonometry to find your angles, and the angle sum of a triangle adding up to 180 degrees. Pause the video now while you write down those worked examples, and then I'm going to give you some questions to try yourselves. Okay, 6 questions for you to try. The first 3 are just about using trigonometry to find an angle. The second 3 are about using your understanding of trigonometry, Pythagoras, and angles in a triangle to work out all the missing information. Just to be clear on that last question on 2C, this is an isosceles triangle. Sorry, I should mark that in to make that clearer. Everything else is right angled. Alright, pause the video now while you have a go. Good luck. Okay, so let's look at the first 3 to start with. So I've got opposite and adjacent here, so I'm using inverse tan of the opposite over adjacent. Inverse tan of 10 over 5 gave me 63.4 degrees. Here I've got my adjacent and hypotenuse, so inverse cos of 8 over 12 gave me 48.2. And here I've got my opposite and hypotenuse at inverse sine of 3 over 5. So hopefully we all managed to get those 3 angles correctly. Gonna have a look at question 2 now. So I used Pythagoras to find this missing side. 8 squared take away 5 squared gave me 6.2 meters. Give yourself a tick if you got that. I then used my opposite and hypotenuse, so inverse sine of 5 over 8 to find this angle B. Gave me 38.7 degrees. And then I used the angle sum of a triangle equals 180 degrees to give me 51.3 degrees here. For part B, I've used my sum of angles in a triangle to find out that this angle is 70 degrees. I then used the tan ratio using 4 and B to find that B was 4 over tan 20, which is 11.0 meters, and C was 11.7 meters. You could have done it in a different way using this angle that you'd already discovered. The fact this is isosceles triangle tells me this is 70 and this must be 40 to make the angles add up to 180 degrees. I need to find the length of this side here, so I'm going to divide the triangle into 2, and that tells me that this length, which is half of the base, which I've called A, is cos 70 times by 10, gave me 3.4 meters. I need to double that because I'm looking at the whole base, it gave me 6.8 meters. Okay, so give yourself a mark there. Each of these are worth 3, so give yourself a mark there out of 12. If you need any more assistance on this topic, then please take a look at Hegarty 511 to 512. Well done.